Okay, ladies and gentlemen, good day all. Today we are going to look at electric field intensity. And if this is the first time you are coming to my YouTube channel, let's click on subscription so that at least whenever we uploaded new videos, you will be able to see notification. So now, introduction to electric field intensity. Electric field intensity is a measure of force experienced by a unit positive charge placed in an electric field. So when we say an electric field intensity, it is a quantity that trying to describe the relationship between a charge and the force. And as we can see from the definition, electric field intensity is represented as capital letter E is described as a force that is F divided by positive charge that is Q. So this is the formula for electric field intensity. So electric field intensity is equal to force all over charge. And remember, from one of our previous videos, we describe the Coulomb's law, where we have force F is equal to K Q1 Q2 all over R square. And this Q, this K is constant. The K is constant, representing as 1 all over 4/5 permittivity of every space. So therefore, K is the same thing as 1 all over 4/5 permittivity of every space. And it has a constant value which is 9 times 10 raised to the power of 9. So wherever you see K, you either write it as 1 all over 4/5 permittivity of every space or 9 times 10 raised to the power of 9. So you see from here, you can relate electric field intensity and the electrical force. So you can see here we can set electric field intensity, and we know that F, which is 4, is the same thing as K. You can use small letter q and capital letter Q all over R square. R square, it means distance of separation. And then we have times, as we can see for the electric field intensity, is F all over Q. So then now we are now going to say 1 all over Q. So this Q here will take care of this Q. Therefore, at the end, we are going to have electric field intensity is equal to KQ all over R square. So this is a formula for calculating electric field intensity. So you can use this or you can use this to calculate electric field intensity. So ladies and gentlemen, these are the two ways you can relate electric field intensity and the electrical force. And these are the two important formula that mostly used in calculating electric field intensity. So without wasting much of our time, let's look at, and very importantly, this electric field intensity is a vector quantity. And when we say something is vector quantity, it means that it has both magnitude and direction. So that is why we use electric field lines to indicate the direction and the magnitude of electric field. So electric field intensity is a vector quantity indicating that it has both magnitude and direction. And as you can see from here, this is the formula that we just tried. You see for force, this is the formula for electrical force, where we have F is equal to 1 all over 4/5 permittivity of a free space Q, capital letter Q, small letter q, and then R square. This 1 all over 4/5 permittivity is what I just described as K. So by definition, electric field intensity E is equal to F all over Q. So therefore, electric field intensity can either be, since we said 1 all over 4/5 permittivity of a free space is K, so we can see E is equal to KQ all over R square. So the Q stands for charge, E electric field intensity, R distance of separation. So understanding electric field intensity, it helps in analyzing the behavior of charges in various fields. So if you are able to understand the electric field intensity, it will help you to understand the behavior of charges in any electrical field. So ladies and gentlemen, without wasting much of our time, let's look at some examples. Find out the magnitudes and direction of the electric field due to a point charge of Q, of 30 microcoulomb at a distance of 1 meter away from it. So the first thing that we are going to do here, we are going to derive the data in the question. So as we can see, we have Q, which is the charge, and it is giving us 30 microcoulomb. And don't forget that this micro is a submultiple unit indicating 10 power minus 6. So therefore, this one is the same thing as 30 times 10 raised to the power of minus 6 coulomb. And then we have the distance, which is R, as 1 meter. And then what we are looking for is electric field, because we are asked to calculate or to find out the magnitude and the direction of the electric field. So it means that we are to find electric field intensity. So now how are we going to get this? It's simple. We apply the formula that said electric field intensity is equal to KQ all over R square. And the K is a constant value, the same thing as 9 times 10 raised to the power of 9 times the Q is 30 times 10 raised to the power of minus 6. Then we now divide it with the R, which is the distance of separation, is R square, which is 1 square. So if we now take our calculator at the end, we are going to get 2.70 times 10 raised to the power of 5. And what is the unit of electric field intensity? The unit of electric field intensity can be volt per meter or Newton per coulomb. So let's use Newton per coulomb. So this is the answer for this question. So then let's look at also another example. This. So I hope you understand this example, and if you have any problem, you can ask on the comment section of the video. And don't forget, after this video, I will send you more questions to try, so that at least you will be able to answer similar questions in the exam or your CA. So let's look at another example. So from here we can see, ladies and gentlemen, in a vicinity of a point charge QZ, a charge of 0.2 microcoulomb is placed in such a way that the force of 4 times 10 to the power of minus 5 Newton is applied to it due to this charge. Find out electric field produced by this unknown charge Q. So you see at this point, or from these questions, we can clearly see that we are given two parameters and we are also asked to calculate electric field intensity. So the charge, which is Q, we are given Q as a charge, and this Q is equal to 0.2 micro 0.2 micro coulomb. Don't forget that micro is something as 10 power minus 6 coulomb. And then we have the force, which is F, is given as 4 times 10 raised to the power of minus 5 Newton. And what we are to calculate, E, which is electric field intensity. So from here, I think, ladies and gentlemen, this is very simple. Electric field intensity is equal to force all over Q. And we are given the force here as 4 times 10 raised to the power of minus 5 divided by the charge, which is 0.2 times 10 raised to the power of minus 6. So when you take this and divide this, when you take 4 times raised to the power of minus 5 divided by 0.2 times raised to the power of minus 6, it's going to give us 200 Newton per coulomb. So this is another examples on how to calculate electric field intensity. So please, ladies and gentlemen, don't forget to subscribe, follow, and join my YouTube community. And in the next video, we are going to look at electric lines of forces. Thank you very much and see you next.